In our society, we've all got very used to having the fat broadband connection, and we take it for granted when we have it. However, many people living in rural Britain don't enjoy that. Now, if we think about Zenzic CAM and its aspirations and ambitions, it's to bring connected and autonomous mobility across the UK in a very inclusive way. In order to travel smoothly and safely, excellent connectivity is needed, but it mustn't be connectivity at all costs. It should be connectivity where a computed answer from MIDAS can mean less expensive hardware is used, maximum coverage is gained, and there's no wastage in terms of expensive carbon-hungry equipment that you don't need. That's PolyChord's solution. Our main mission is to use a unique form of data science to interrogate real-world problems. Our data science has got powerful next-generation capabilities. The way forward for us is with collaborations with companies. They've got a lot of data often. They'd like better insights into it to get action and results. What we're doing in the CAV space is using product driven by PolyChord called MIDAS, which can optimize the placement of sensors, transmitters and receivers in a network. This has got advantages for both cost and for reducing carbon. We really wanted to work with Warwick Manufacturing Group because their level of engineering know-how and network capability was massive. We've been using a real vehicle in a digitally simulated environment.
We're here today with WMG. They have antennas that are placed around the campus, and they have this simulator here where you can drive around in a car in the simulated world, get a sense of how this 5G network of transmitters is performing.
Today we've optimised the position of various transmitters around the campus, and we want to look at that in comparison to the existing network, so see how much improvement we've gained by running our optimisation pipeline on that. And then the virtual car, we'll be able to then drive around the simulation and see how the experience of the user in the car, so how much signal their actual phone or the car itself will be receiving as it drives around. Once we've looked at the existing setup, we'll load our new optimised, our improved version, and then see, okay, these dead spots we identified with the current setup, are they still there?
We have run these tests now, and we have seen that using our optimised antenna positions, we see that those dead zones have disappeared, so we were able to make an improvement there.
We're really pleased, even with this most simple moving some antenna around, we're already seeing about 70% of the places on this campus had experienced an improvement in their signal.
And we're going on to a next phase of activity with SMLL, where we'll be doing an extension of that using real vehicles on real roads. For an SME like us, taking part in the Zenzic CAM has definitely helped us expand what you're doing and achieving into a real-world scenario. By engaging with Zenzic and CAM, we can make good contacts within the telecoms industry who can see what we've been doing and help us bring it into a product they can really use and benefit from. The Zenzic program has enabled my team of very able data scientists to pool their resource with the engineers at Warwick Manufacturing Group, and this has been, like a lot of our collaborations, a double learning experience. I think we have learnt a lot from Warwick, and Warwick have learnt from us. We can learn from people we collaborate with, and we can learn from organisations like Zenzic. The future of PolyChord is already looking very exciting. We've had a phenomenally busy 12 months. We're pushing forward where we've got commercial traction, and we're working with people like National Highways, Transport for London and LNER. It's clearly a really important sector for us. It's a sector where better data science is definitely needed. That's something that PolyChord is delivering and can deliver much more effectively for people who need it.